All right, so a normal distribution is a distribution that follows the bell curve. So a normal distribution is considered symmetrical about the mean, but it's not necessarily, it doesn't have to be perfectly symmetrical about the mean. A normal distribution is a very common probability distribution. So like I said before, now it's very rare to have a perfectly symmetrical data distribution. However, it is perfectly common for you to have an approximately symmetrical distribution, and that would be called a normal distribution. Now, again, I'm going to refer to this as the bell curve model. Now, in a normal distribution, the estimated rule is that about 68% of your data values fall within one standard deviation from the mean. So for example, remember your axis of symmetry is your mean here. This would mean that about 34% of the data values fall within one standard deviation below the mean, and about 34% fall within one standard deviation above the mean, and that equals 68%. And about 95% of your data values will fall within two standard deviations of the mean. So there's about 13.5 plus 34% of your data values that fall within one standard deviation below the mean, and 34% plus 13.5 of your data values fall within two standard deviations above your mean. And so then about 99.7%, so a majority of your data in a normal distribution will fall within three standard deviations of the mean. And that's how we get this symmetric bell curve here. So, and that's shown on the figure. So if we go to number 1, it says a set of data that is normally distributed with a mean of 5. Whoops. So we have a data set that has a mean of 5. It says what percent of the data is less than 5. So in my normal distribution, okay, my mean is always this axis of symmetry here, and my mean in this case is 5. And we want the percentage, and I'm going to actually draw the rest of my values in. So within 3 standard deviation, this is 2.5%. Within 2 standard deviations, this is 13.5%. And then within 1 standard deviation, this is 34%, and then also on the other side. So we want what percent of the data would be less than 5. So if that dotted purple line is the mean of 5, then the percentage of my data that is less than 5 would be this category, which is 34%, plus this category, which is 13.5%, plus this category, which is 2.5%. So if I do 2.5 plus 13.5 plus 34, I wind up with 50% of the data would most likely fall below the mean of 5. Now, when I say most likely, or when I say about, this is just the estimated rule, all right? Not every normal distribution will be exactly following these percentages, but it will be pretty close to these percentages in a normal distribution. So most likely about 50% of your data in a normal distribution will be below the mean. All right, and then about 50% will be above the mean. All right, number 2. The life of a fully charged cell phone battery is normally distributed with a mean of 14 hours and a standard deviation of 1 hour. We want the probability that the battery lasts at least 13 hours. So this means 13 hours or greater. I'm going to go ahead and draw my bell curve again. All right, and my mean here, this is my mean of 14 hours. And it's probably best if you get the hang of this, drawing the symmetric curve and knowing the percentages. So within 1 standard deviation, it's 34 above and below. Within 2 standard deviations, it's going to be 13.5. Oops. And then within 3, sorry, 2.5. Okay. Now, we know that we want to determine at least 13 hours. So, what that means is if I do 14 minus my standard deviation of 1, that means that 13 hours falls within 1 standard deviation of the mean, which is 14. So, if I want at least 13 hours, which is 1 standard deviation below the mean, so that's this chunk that I'm highlighting, then I also want, because again the word at least means it can be greater than 13, so that means I also want all the intervals that are greater than that 13 as well. So if I do 34 plus 34 plus 13.5 plus 2.5, I wind up with 84%. Now if I asked you for at least 12 hours, then 12 hours I would need to take this 13 here and subtract another standard deviation to get 12 hours, which means 12 hours lies within 2 standard deviations of the mean. And then I would be including this amount as well, because that's 2 standard deviations below the mean. So keep that in mind as you're working through these normal distribution problems. But basically, it will help you visualize this by drawing your bell curve and knowing the percentages and where they go. All right, that brings us to the end of this lesson.